German mathematician Karl Riemann. When I did Mario Kart, it was fine. The Mario Kart block was fine, but the
Mario Kart last year got so wild.
oh, so when I did Mario Kart 2 years ago,
I mean.
Mario Kart when I did it 2 years ago was fine. Like Mario Kart was really sedate, settled. Everybody was really polite. But then I did Smash Brothers, the second block, and it got like it was like the Lord of the Flies. Like kids were hanging from the light fixtures. It was nuts.
Do you think it's necessarily caused by?
It was caused by Smash Brothers. Yeah, I'm not gonna do that again. And if that's what happened with Smash Brothers, I don't want to think about what zombies would do. No.
How about Madden?
No. 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 I can shut this one further. SUMS. Yeah.
Nice.
Okay.
I was gonna say waffles first.
All right. So, quiet. So how a Riemann sum works is if you have something that's curvy and you can't exactly find out what's underneath it, you can use an approximation to find out what would be underneath it using either a left hand or a right hand sum. So let's take a look at a graph. Like let's say y is equal to, I'm going to do x squared plus x plus 2. And the interval I'm going to look at is -2 to 1. So I'm going to use a piece of graph paper here for this. So I'm going to grab a piece of graph paper. I should have somewhere, but I don't. So I'm just going to make my own little graph on my piece of notebook paper here. It's okay. You can use your graph paper for your notes. I'm just going to make my own little piece of graph paper here in my notes. So, meow, meow. Now, to make my life easier, I'm also going to use my calculator for this, for parts of this, and I'm going to show you how you can use your calculator to make a lot of this easier, but I'm going to do that after I've made your life a little bit more difficult.
Oh my gosh.
I know.
So it's like every single time you've ever taught us something in math.
Not every single time. So my x interval needs to go from -2 to 1, so I'm going to do -2, -1, 0, 1, and I'm going to find out what the y's are going to be. So if I put -2 in for x, I'm going to get 4 plus -2, which is 2, plus 2, which is 4. If I put in -1, I'm going to get 1, plus -1, which is 0, plus 2, which is 2. If I put in 0, and you get back out 2. If I put in 1, I'm going to get 1, plus 1, which is 2, plus 2, which is 4. You guys with me on how I filled that out? Now, if you wanted to, what you could also do is there's a feature on your calculator called the table. I know that we've used it before, but finding it on the TI-86 is a little more complicated than finding it on the 84s. So how you would find it? So if you go to the table, just hitting the table button, it brings this up, and you can go to table. But if you don't actually already have your equation filled in, like it brings this up, but that's not really helpful. So to actually fill in the equation, press the graph button, and it brings up this menu. You want to go to y of x, so press F1 to bring up that feature. So y of x, and we're going to enter this function, x squared plus x plus 2. So I'll use x var for wherever I want to do x, so I'm going to do x squared plus x plus 2. Now when I go back to the table, so I'm going to hit table. Now your table setting might be weird because the last time we used the table we were using really small values when we were doing limits.
0.01.
Right. So I'm going to do table set instead of hitting table directly. So table set, which is F2. And then I'm going to have the table start wherever my interval starts, which is -2. So -2. And then I want my delta table, which is how much the table changes each step. I'm going to have that be 1 because I just want it to go from -2 to -1. I want it to change by 1. Yep, delta means difference. And then I want it to jump to the table, so I'll hit F1 to have it go to the table. And I can just use this to do all that math I just did. I can have my robot buddy do it for me. Right? Now, I can fill in my graph over here. So I'm gonna... What? Yeah, because it's symmetrical. So I'm going to go -2, +4, -1, 2, 0, 2, and then 1, 4. So what happens to this is it makes this shape. And then, so Riemann sums come in two different varieties, and we're actually going to be using both of them today. The two varieties are left-hand Riemann sums and right-hand Riemann sums. So a left-hand Riemann sum means that you're going to be making rectangles that start at the left and go to the right, and a right-hand Riemann sum starts at the right and goes to the left. So I'm going to be using some colors here to demonstrate that. So the blue marker is for the left-hand Riemann sum, and the pink marker is for the right-hand Riemann sum.
I don't like colors.
Okay, you can, I don't know, do something to approximate that. Pencil and pen, be creative. So what I'm going to do, so I've got this point right here, and I'm going to draw a box going from the left to the right. And I'm going to do that all the way across until I reach the edge of my interval. So I have three boxes. I have a box from here over, from here over, from here over, and then I stop at the edge of my interval. So I don't make another box here, because another box here would go outside of the interval. The interval needs to stop at 1. Does that make any sense? So for my left-hand Riemann sum, my area under the curve is going to be way bigger than it should be, because this box goes way outside of what's underneath the curve. My area under here is going to be 1 times 4. So the area in this box is 4 plus the area in this box, which is 2, because it's 1 by 2, plus the area that's in this box, which is 1 by 2, which is 2. And then I don't have a box over here. So I went way outside here, and then I have all this empty space here. So this is just like a super rough approximation about what the area underneath this curve should look like. So my left-hand Riemann sum is 4 plus 2 plus 2, which would be what? Okay. Now I'm going to make a right-hand Riemann sum. Right hand. And so the right-hand Riemann sum instead is going to go from the point to the right. So I'm not going to make a point, I'm not going to make a box from here over, because that would be outside of my interval in that direction. But I am going to go from here over, and then I'm going to go from here over, and then I'm going to go from here over. For the box?
Yeah.
So my right-hand Riemann sum, I'm not going to start at this dot and go over, because that would be on the left-hand side of my interval. My interval shouldn't start until -2. But I am going to start at this dot and go to the left, because I'm making a right-hand Riemann sum.
Okay.
So I'm going from the dot and going to the left. And then I'm going to go from this dot over and from this dot over. And now I'm going to add these up.
4 plus 2 plus 2.
So 4 plus 2 plus 2. In this case, it adds up to be 8 as well. And then I've got a left hand and a right hand. I would average these two together. I wasn't thinking when I made this, it's going to average to just be 8. So I would do 8 plus 8 divided by 2, averages out to be 8. So this is my approximation using my hands. You can use your TI-86 to make another approximation. I need your instruction manual for how you can use your TI-86 to do that. I also included on here how to use your TI-86 to convert from a decimal to a fraction. Because I know some of you were wondering how to do that. Because it's not as easy on the TI-86 as it was on the U-4. I even put 3-hole punch this so that you can maybe hold on to it.
Nice.
All right.
Look at that.
So if you want to integrate the function, now this is only going to give approximate answers. So if I have an assignment where I'm asking for exact answers, you can't just use your calculator to do it. You have to actually do it by hand, and I'll show you how to do that later. That involves the antiderivative that we're going to learn about next week. But so here's what we're going to do. I'm going to exit back out to the main menu. So I'm going to hit exit here, which brings me back to the main menu. So to graph this, I'm going to press graph to bring up the graph menu. I'm going to press y of x to bring up the y of x menu to alter the graph. I already have my function in there. I'm going to press enter. I'm going to enter the function I want to integrate. Be careful that I enter the function correctly. If I make a mistake with my syntax, meaning if I put like a comma in there that shouldn't be there, so like the comma button's down here, if I put a comma that shouldn't be there, then it won't do anything. The TI-86 will just go on strike and like pout for a little bit. Okay, press exit to bring down the menu that's needed to graph. So press exit, and then press F5 to graph. All right, so here comes the graph. Looks like that. Press more, which is right here, and then press F1 for the math menu, and press F3 to integrate. So it asks you what the lower limit is. In this example, our lower limit is -2.
What do you go to now?
So you press more, and then F1 for the math menu,
Yeah.
F3 to integrate. Enter the lower limit, in this case it's -2, and then enter the upper limit, in this case it's +1. It does that little shady thing, and then it tells you approximately what the area under the curve is. In this case, 7.5.
Oh, that's nice.
So our Riemann sum of 8 was pretty close. Kind of, sorta. So by hand, like they had to way back in the 1600s, using technology, like we can now because it's the 21st century.
How exact is using your calculator?
It's pretty exact. I mean, it's
Compared to using the Riemann sum.
it's gonna be for most things, you know, 20% more close. I went through your assignment and doing the Riemann sum, if you do both left and right hand and then average them, it gets pretty darn close. If you only do left hand or you only do right hand, it's pretty far away. But if you do them both and average them, it gets pretty darn close. Kind of, sorta? All right.
So you said there will be some that you'll have to use your calculator for and some that you'll have to
Well, what you're going to do for today's assignment is you're going to do all of it. So, like, there's only 8 problems on today's assignment.
8 assignments?
I know! There's only 8 assignments on today's problem. There's only 8 problems on today's assignment. And to do it, you are going to use your scrap paper, which can be found conveniently in the thingy thing labeled graph paper. I'm going to grab a piece of graph paper for myself and not you, because I'm selfish. I'm not.
You got a beard now.
That's fine.
You know what? Just because he doesn't have a change.
Some of the other teachers were asking if I had photos of myself without a beard, and I do. They're all from when I was like super young though.
Like even in the summer you still rock it?
Yeah.
Oh, man. That's commitment.
Yeah, no, like the only pictures
Not really even hot.
the only pictures I could find of myself without a beard are from when I was like 19.
Ooh, can we see?
Sure. So
No way, you look so different.
there's 19-year-old Mr. Taft without a beard.
Oh my gosh.
Oh, wow.
Wait, at least stand next to it so we can compare.
Sure.
Hey, take off your glasses.
Fine.
Dang. That is closer. That looks a lot.
See, I have another one on here.
That is. Oh, Oh, Mr. Tacker's still recording.
I know I am. There's another one.
Dang. That bandana?
That was a bandana, yep.
Really, Chris?
Yeah, that's me. It's Mr. Taft, yep, that's who I was. All right. So, let's go through a few of these. I'll go through question number 1. Question number 2 is really similar, and then I'll go through like maybe 3 and 5. So, question number 1. What you need to do. So the easiest way to do this is to graph it out and then use your graph. Trish was very curious because she was like, "We've seen you without your beard, haven't you?" And I was like, "No, you have not."
Never?
The whole time I've been here, the most you've seen me without is I've had a goatee.
Yeah.
So you've seen me without this. But like, I've always at least had a goatee.
I'm just gonna use my grass sticky notes.
That's fine. Anyway,
How long it take things to for?
I don't know. There was no agreement.
Well, at least until it grows back.
Sure. So, okay. 0, 3. So, 1, 2, 3.
The direction of it growing back seems to be
1, 5, 2, 3, 4, 5, and then 9, 6. Yeah, but Mr. Coriel, like, sometimes he'll have it like as big as it is now, and then he'll go to nothing. So, like, you have seen him clean shaven before.
Yeah. That's what we were saying. It's kind of growing back for some reason.
9.
Yeah, getting it from where he is now to.
Alright, so. Mirror. 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 And. Mirror. Alright, so
I need a ruler.
they're in the box over there, or in the drawer marked rulers. So for this one, it says specifically to use left-handed Riemann sums. So you're going to start at the left and move to the right. So starting at the left and moving to the right, the rectangles are going to look like this.
I thought it was taller on the left. What's your test?
No, so you start at the left and move to the right. So like it's not that it's tallest on the left, it's that you start at the left and move to the right.
Well,
All right, so let me try and explain it again then. That's fine. So when you're doing left-hand Riemann sums, so like I'm going to start here at the left and move to the right. So this is the first stop that I have. So this is where I'm going to start the box, and I'm moving to the right. And I'm only going to go until there's another place for me. So like I'm going from 0 to 1. So I'm just making a rectangle that is 1 unit wide. So I'm going over 1 unit and then down. And then I'm going to go to wherever the function is at the next unit, which is here. I'm going to go over 1 unit and then down.
so if there's like 2 spaces in between, will it make like a point?
Actually, no, that makes more sense. Okay. And then from here, I'm going.
I think you graphed it.
Did I?
Because it's supposed to be 2, 4 is the next one.
Yeah.
2, 4?
No, it's
Well,
2,
no,
3.
like it goes from the x being at the dot at 2 to the x being at 4, not at 3 there.
Okay.
Oh yeah, there should be a double space there.
I'll fix it. I'll fix. So, oh yeah, no, you're right, I did. You were right. So, 0, 3, 1, 5, 2, 3, that was right. And then 4, 5. So 3, 4, 5. There we go. And then 9, 6 is here. Okay. Thanks.
Isn't that still off? The farthest one's still off on your graph?
Which one?
It should be to the right one more space.
This one?
Yeah.
So
Only
1, 2, 3, 4, 5, 6, 7, 8. It is. Look at you, Eagle Eye.
I didn't know if it made a difference.
No, it does. 4, 5, 6, 7, 8, 9. It does, it does. I know. Look at you. Okay, so this is going to go over 2 spaces and down. I was wondering why my answer was off when I was doing making the answer key for this. And then this is going to go over that many spaces and then down. Alright, cool. So when you're making this up, so this one here is going to be 1 unit by 3 units. So what's the area of that rectangle?
3.
This one is 1 unit by 1, 2, 3, 4, 5 units. So 2 units by 3 units. And then this is 5 units.
By 5.
Mm-hmm.
So 25.
And then when you're adding these up, 3 plus 5 plus 6 plus 25.
So 25 plus 5 is 30 plus 6 is 39.
39.
So 39.
And is that our answer?
So according to the left-hand Riemann sum, it's 39 as the area. If we were to do a right-hand Riemann sum, we might get a different number. But the left-hand Riemann sum says the area is 39. Okay? Alright, so let's look at number 3. Number 2 is super similar. Let's look at number 3 though. So for number 3, we've got y is equal to x squared over 2 plus x plus 2. And then the interval is from -4 to 0. So first thing I'm going to do is I'm going to enter this into my calculator. So to get out of this screen, hit exit and exit again. I'm going to go to my graph screen and hit y of x, and I need to change this. So I'm going to clear it out and I'm going to enter that. So I'm going to type exit
Yeah.
and then exit again.
Yeah.
And then if you want to go back in, hit graph and then F1 to go to y of x.
Okay.
Divided by 2 plus x plus 2. And then I want to look at my table because I'm going to graph it from -4 to 0. So I want to be able to tell exactly what those are. So x, y, -4, -3, -2, -1, 0. And I want to know my y values for those. So let's go to table, and there we go. So -4 is going to be 6, -3 is 350, -2 is 2, -1 is 150, and 0 is 2. Now to graph it so that I can do the left and right hand Riemann sums, just going to make a neat little x and y axis here. So 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. 2.5, 2, 1.5, 2. So it looks like this. Alright, so to do the left-hand Riemann sum, you start at the point and then move left. And you don't go any past the interval. So I'm going to start at -4 and move left for my left-hand Riemann sum. So these are what my rectangles would look like. So for my left-hand Riemann sum, left hand. So this first one, 1, 2, 3, 4, 5, 6, is going to have an area of what? Great, 6. What's the area of the next one? So plus 3.5. And the next one? And then the last one? 1.5. And then I don't have another one because that would go outside the interval. So my left-hand Riemann sum is going to add up to be, let's see, 5 plus 2 is 7, plus 6 would be 13. So the left-hand Riemann sum is 13. Now I'm going to do the right-hand Riemann sum. So I wouldn't go to the left of here because that would go outside the interval, but I will go from here over, from here over, from here over, and from here over. So I've got this box, this box, this box, and this box. So this one has an area of 3.5, right? Am I confusing you guys? What's this one? 2. This one? 1.5. And this one? 2. So the right-hand Riemann sum. So this is 5. So 9.
7.
So the average of the two, 11. So that's what I would find as my area under the curve by hand. Now I'm going to find what it is using my calculator. So you got those steps printed out, right? So you already have your function entered. So all you need to do is go to the graph. So you need to be able to get down to that graph menu. That graph menu, to get that down, you have to hit exit. And now that knocks it down. To graph it, you push F5. It thinks for a second, and then it's going to show you the graph. And then here comes the menu. Now you need to push more to bring up more options. F1. More is right next to exit. It's right here. Push F1 to bring up the math menu. And then that F3 is the integration option. That symbol right there means integrate. Remember I showed you that at the end of the class yesterday? So push F3 to integrate. It's going to ask for the lower limit. The lower limit in this case is -4. And then the upper limit is 0. It's going to do the shady thing. And then it's going to tell you approximately what it thinks the area under the curve is. And so by the calc, it's 10 point, and I'm going to round to 2 decimal places here.
Or 2/3.
Sure, 10 and 2/3. 10.6 repeating, 10.67, 10 and 2/3. Sure. So if we had just gone with the left-hand Riemann sum, we'd be pretty far away. And if we'd just gone with the right hand, we'd be pretty far away. By averaging them, we're pretty close. Does that make sense? So 4, 5, 6, and 7, it's the same thing. Do you want to go through more of this together? Or are you guys good?
Yeah.
More? All right. I'm excited about this. It's my favorite topic in math.
Is it really?
Well, it's one of them. I have a lot of favorite topics in math, but this is definitely one of them. I kind of love calculus. I love it so much. Okay, so number 4. We got y is equal to -x squared plus 12. So our interval here is -1 to 3. So when we make our table, x and y, x needs to go from -1 to 0 to 1 to 2 to 3. So to get back to where we were, I'm going to hit exit. And then I want to change the thingy thing. So I'm going to hit graph and y of x. And I want to clear that out and change it to what I need it to be. So I'm going to hit clear. Negative x squared plus 12 And I want to do the table, so I'm going to hit table, table. And I'm going to start at -1. So -1 is 11, 0 is 12, 1 is 11, 2 is 8, and then 3 is 3. Cool. Now I got to graph it. So you can play with scale if you want to here, but there's so many boxes on this graph that like you don't need to play with scale. Oops.
What do you mean?
Well, like you can have each box represent 2 if you want to get up to 12 by changing the scale, but you don't need to. There's so much room on this graph paper, you don't really need to. Because like to get to 0, 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, I can easily get to it. So like if you wanted to though, you could have it be 2, 4, 6, 8, 10, 12. Just remember that you made your scale be counting by 2s on the y-axis then. But you can do that if you want to.
Y-axis.
1, 2, 3,
I'm gonna actually do that because I'm sticky notes.
4, 5. Yeah, I mean that's fine. You totally can do that. It's an option. Alright, so left-hand Riemann sum. So in here, going all the way down. Here, all the way down. Here, going all the way down. Here, all the way down, and then that's it. So this one, this one, this one, this one. So we got how much for our left hands? We got 11 plus 12 plus 11 plus 8. So that's 20 plus 22, which is 42.
So what can I do this 42?
Maybe.
11, 12, 11.
And then for the right hands, we got this one. We got this one. We got this one. And then we got this one. So 3, 8, 11, and 12. So 20 plus 14.
What is the equals you have?
Like a billion?
Oh, 38
Not 38.
is the average, right?
Oh, 38 is the average. Yeah. Soup's the average. And then you use your technology to find out what the technology thinks it is, what your robot buddy thinks it should be. So I'm going to look at my robot buddy here. And I'm going to say more math F3 -3 to 1 shady shady, and my robot buddy thinks it should be 38.67 by calc. Wait a minute. Which part?
I was for 3, what did you get for the calculator?
For 3? 10.67.
What was the calculator one for this one?
38.67.